Now it's a 3-goal advantage as Team 449, the Blair Robot Project, scores.
It uses the same motor to both pull the kicker back against the springs that it charges. Then it uses a ratchet and pull to latch it into place. Then it uses the same motor running in the opposite direction to release it. The way that works is this sprocket is connected to this motor by a chain, and this piece of metal is attached to the sprocket, so when the motor drives, it drives that down, pushes against this piece, a bit of metal pulls the ratchet back, and the ratchet has a pawl spring-loaded and sensorized and everything so that it's able to count how many clicks it goes, and through that we're able to have 5 different power levels for varying ranges. So basically what happens is the motor does something like this, then the ratchet holds it in place and the motor goes back, and then in order to fire, it goes all the way back up to here and lifts the pawl up, so it would look something like this. And it is very cool, and it winds up fitting in a tiny, ridiculously tiny profile. Like, the whole, kicker firing stuff is, this big. Plus the motor back there, and then the rest of the kicker that's attached to it. It used to be that the kicker was anchored at one of these holes to down there, because that's sort of the obvious way to make a kicker. But we found that you're actually able to charge the kicker by moving a bar here and anchoring the springs down here, so that when it moves back, it stretches the spring out and then it gets pulled back. And that actually gives us pretty much the same amount of power and force as the old kicker, but it's much more serviceable and less in the way, and lets us widen the kicker for other things, like putting a vacuum.